Recording. All right, so here's one of the questions. First issue we talked about this unit is graphing polynomials, right? So I'm on the test, in order to make things a little bit to break down or to make it shorter, I'm going to give you the polynomials in factored form. You know, I know you can factor polynomials. That's what you did last unit. Okay, so I'm just gonna give that part to you. So if I give you this polynomial in factored form, your goal is you got to pick the right graph. Okay, so the way we'll approach this, let's make a quick sketch of this thing and then show that it's consistent with, you know, with the choices that are available. Okay. So first of all, if I were to multiply this out, what's the end behavior going to be? What's the power function going to be that determines what the end behavior of the function is?
Upside down x forward.
Okay, so and why is that? If I were to, and you don't have to do this, but if I were to multiply this whole thing out, what would the leading term be?
X to the fourth.
Negative x to the fourth, right? Yeah, everybody agree? So there's one thing that's very useful. So we know x to the fourth, if it's an even graph, we know that the function goes up at both sides, but because we're multiplying by -1, it's going to flip it around, so it's going to go down at both the tails, right? So that's one thing we know. Are there any asymptotes for a polynomial? No. No asymptotes for a polynomial. That's something we get with rational functions, but we don't get that with polynomials, right? So then all we've got to do here is, I mean, we really can almost do this thing without even worrying about picking test points, right? We could kind of just think our way through this. What are the zeros going to be?
-1, -3.
Okay, so we get -5, 0.
How do you know that they're asymptotes?
Because polynomials never have asymptotes. What would an asymptote is what we get, a vertical asymptote is what we get when we have a 0 of the denominator, but it's not a 0 of the numerator. There's no denominator in a polynomial, right? So, right. And horizontal asymptotes are what we get if we have a rational function and either the degree of the top polynomial is the same as the bottom polynomial or the bottom is bigger. But once again, there's no bottom polynomial, so you can't have horizontal asymptotes, right? So we get zeros at -5, -3, and -1. And we ought to, so we can put those on our graph. So -5, we get a 0. Oops. -3, we get a 0. -1, we get a 0. And we can even tell what's going on at those zeros. What's going on at -1? Is it bouncing or cutting the function, or cutting the x-axis? So it's cutting the x-axis, it's cutting the x-axis, and it's bouncing. So we got it, right? If we know the end behavior is down, can't we kind of put this together? We know it's bouncing at 5, and the end behavior is down, so it's doing that, right? It's cutting at 3, so it's got to go through the function, and it's cutting at -1, and it's going down. So that's our graph, isn't it? We don't even really need to test points in between our zeros on this one if we don't want it. I mean, we really can put this together just by thinking about what the end behavior is and what the nature of these x-intercepts are. Are they cutting or bouncing off the x-axis, right? Now, if we want to, I mean, we could test, you know, some test points if we wanted to. We could pick points, you know, surrounding our zeros, like -10, -4, -2, and 0. And if I plug those into my function, and I've got 4 factors here. I've got a constant negative factor in the front that's always going to be negative. I've got a factor that's squared at the end, and anything squared is positive. Any real number squared is positive. So really all I got to do is just check the signs of those other 2 factors in the middle at each of these points. And if I do that, like at -10, I would get everything's negative except the last one's positive, so my overall sign is negative. At -4, I'd get negative, 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 positive, so it's also negative, right? At -2, I'd get negative, negative, positive, positive, overall sign's positive. And at 0, I'd get negative, positive, positive, positive. Overall sign is negative. And so we could, that might help, right? We get the same picture, wouldn't we? But now, we could use that information to see that, I don't want to spend too much time on this, get it. But we know that we're below the x-axis over here, right? So we're down. We're below the x-axis in there, so we're down. We're above the x-axis at -2, so we're up, right? We're positive, and we're negative there. So if we connect all those dots, doesn't that give us, that gives us our same function. Right? So you can do them, but you don't really need to in that case. Up to you. Okay, what about this? So you get one of those first problems, where you've got to sketch a polynomial based on the fact. I'm giving you the factored form of the polynomial, you got to come up with a sketch. Write the simplest possible polynomial function in intercept form, so factored form, right? So you don't even have to expand this out, just leave it factored. This is a pretty simple, straightforward one, isn't it? So what do we get from this x-intercept here is giving us what factor? X plus 6. Okay, this one here is giving us what factor? And now be careful with this one. What's that one giving us? X minus 4 squared. Good, because it's bouncing, right? And so we know that we're getting, our overall behavior is going to be f of x equals x plus 6 times x plus 3 times x minus 4 squared. Now, this got to be negative, doesn't it? My first term, if I were to write out f of x in standard form, I know that I'm going to get, if I multiply all that stuff out, I'm going to get x to the 4th plus a bunch of other stuff, right? But because the function is turning down, the coefficient, is it going to be 1 or -1? It's got to be -1, doesn't it? Right? So we've got to put a negative out front and we're done. Okay? Make sense? Good. No big deal. You can do that stuff. So now if we're multiplying polynomials, and I'm not going to, on the test, in order to keep it a little shorter, I'm not going to give any just redonkulous, where there's just millions of factors and things. It's going to, just as long as you know the concepts, it's going to be pretty straightforward, right? So what do we get then? If we just, all we got to do when we're multiplying, right, when we're multiplying, essentially, it's just like simplifying, because I know I've got this factor times this factor over this factor times this factor. So first of all, I can write it without even the multiplication sign. I can just put one big division bar and everything on top. What am I going to get? A -x times an x minus 1 times a -5x on the top, right? I've got those three factors when I break it down. On the bottom, I've got a 6 times an x minus 1. And then if I combine, I've got a monomial here and a monomial there. So -x times -5x gives me positive 5x squared, right? And then we can see that the x minus 1s are common factors, so those cancel. And so my final answer is just 5x squared over 6, right? All I'm doing there is just factoring everything out and canceling like factors. But are there any values of x that need to be excluded? 1. Before I do my canceling, we have to be careful, because it's, after I do my canceling, I don't see that x minus 1 on the bottom, but of course, there is a factor on the bottom before it gets canceled of x minus 1, so I have to exclude 1 from my answer. Okay? With division, same kind of thing, right? We know that we're going to start off, let's factor this first quotient. So on the top, it factors into x minus 6 times x plus 4. Bottom is x plus 6 times x minus 4. And we're dividing by this other quotient. Now, we haven't divided yet. Yes, sir?
So on that last question, the answer is it?
Well, there's two parts to it, right? There's going to be, we want to know what's the simplified version of this, right? So if I simplify it, that's my first answer. That's what that product is equal to in simplified form. But the part 2 is what values have to be excluded from the domain. 1. Okay. With this one, so I know I've got the white quotient divided by the yellow quotient. but I want to factor the yellow quotient also, right? Because anything that ever shows up in the denominator, any factor that ever shows up in the denominator could cause values to be excluded from the domain. So far, what are the values we have to exclude? Okay, I have to exclude a -6 from there, a +4 from there, and a -4 from there. Good. Okay, so from the denominator of the part that hasn't been flipped yet, I still have to exclude that -4. Well, I'm gonna go on, when I divide by a fraction, I just flip and multiply, right? So all I have to do is take this yellow fraction and just flip it and find that product. Right? But after I flip it, do I get any additional values I have to exclude? -6, right? So if we look at where these are coming from,
Which is usually get
right, so I've got my,
zero
so I've got, there's where that guy comes from, right? There's where that guy comes from. And then, there's where that guy comes from. But then after I flip it, I've got this additional, let's see, did I cancel? Oh, no, this comes from here, right? Okay. Before I cancel it, I have to exclude 6 also, right? And then at that point, I can just cancel all the like factors. So those guys cancel, on top I get x plus 4 times x plus 4, so x plus 4 squared. You can leave it in factored form. You don't have to expand that out. On the bottom, I just end up with x plus 6 times x plus 6. Okay, questions?
How can you get a 0 from the original one, but then get 2 more?
You mean, how do I get,
And you got four.
you mean excluded, you mean excluded
Yeah.
values?
or- Yeah.
Well, because for this, if I'm gonna divide this expression by this one, well, this expression can only exist if I exclude the values +4 and -4.
Oh, is it because, oh, and then it's gonna be on the denominator, so
Right.
the numerator, okay.
So the point is, before I flip, whatever's in the denominator, it could contribute some values that have to be excluded before I flip and after I flip. So essentially, because this term is going to get flipped, we have to figure out what the zeros of the bottom are and the top are, and both of those are gonna end up causing us to exclude values of x from the domain.
Technically, the whole thing's gonna be in the denominator.
Yes, at one point or another, all the factors end up in the denominator,
Oh.
yeah, and you have to exclude them all. That's the tricky part with the quotient stuff. Yep.
Are we gonna have adding and subtracting?
Yes, yep, I'm gonna give you one adding and subtracting problem. So let's go through one of those also, right? So with adding and subtracting, remember, this is just like it is with regular fractions, we just wanna get a common denominator, right? So what is our least common denominator for this one?
X squared and y minus
Well,
y.
I don't want it I want it in factored form. Okay, x plus 3 times x minus 3 is the smallest product of factors that includes all of my denominators at least once, right? Okay? So then all I've got to do is I need to get that common denominator in each of those terms, right? So the first term, what do I need to multiply top and bottom by to get my common denominator from the first term? X minus 3. And there it is, right? There's my least common denominator. Okay? Minus next term. What do I need to multiply that one by top and bottom to get my least common denominator? X plus 3. And there it is, right? And then finally, last term.
X plus
We multiply this one by, It's actually a green, isn't it? Yeah. Okay, so then, now we want to, what's our next step? Think what you would do with numbers. We're going to write this with one big common denominator, right? So we're going to take
Combine the like.
everything over my common denominator. And then everything on top is what I get, right? So what am I going to get from, if I multiply those out?
X squared minus 6x plus
X squared minus 6x plus 9.
Baby.
Minus, what do I get if I multiply those out?
5x plus
5x plus
15.
15.
So I gotta put in parentheses, right? 5x plus 15 plus, oh, what happened there? Oh. Plus, you had it on a correct one. What do I get there?
X squared plus 9x plus 18.
Okay, make sense?
Yeah.
Okay, yes, sir.
If you just go back up to that, like, the original form, what if there was a negative in front of one of the denominators?
Okay, so if there's, it's a good question, if there's a negative in front of one of the denominators, what you should do is multiply the top and the bottom of the fraction by -1. Although, I thought about that last night, I rewrote all those questions so they won't do it again. Okay, so on the test, it won't happen that way, okay? And I think it's kind of,
Well, if only one of them had it, and you multiply the whole thing, then wouldn't it make the other two negative?
you multiply the top and the bottom of the fraction by -1, so you're not changing, because -1 over -1 is 1. You're not changing anything, but you're just making it more convenient, right? But that's what you should do, Kyle, because you don't want to have a leading coefficient that's negative on either the top or the bottom. I mean, on the bottom. Top you can have it, sorry. Top's fine. Okay, now I want you to notice something, a place where I think people could make a mistake on this, is when you're multiplying all this stuff out, remember that because I'm, like, for example, I'm subtracting that entire product, does it make sense that that has to go in parentheses, right? The mistake people are likely to make on that is they're gonna say minus 5x plus 15 without parentheses, and then when they collect like terms, they're gonna make a mistake, right? So then, next step would just be, the top, we're just gonna simplify. So what do we get on top if we combine all those like terms? I'm gonna get an x squared plus an x squared, so a 2x squared. I've got a negative 6x minus a 5x is negative 11x plus 9x
Negative 2x.
minus 2x. I've got a 9 minus a 15 is negative 6 plus 18 plus 12. Okay, and it's all divided by. And if I multiply the bottom out, what do I get?
X squared minus,
Well, actually, you know what we should do? What am I doing here? We don't want to do that. We want to leave it factored if you can, right? So we get x plus 3 times x minus 3. On the top, can I factor anything out on top? 2. Leaving me with x squared minus x plus 6, right? And then on the bottom, I've got my x plus 3 times x minus 3. Can I factor the top anymore? Okay, I can.
I don't think that works.
What's that?
Would they give you a negative 6? That doesn't work.
Did I mess something up?
Well, when you factor, you can't act.
Yeah, there's no way you can
Because
have
x
a
minus
negative
3
x
x
plus
plus
6.
Oh, you're right. Yep, you're right.
If you're constant negative.
Okay, so it doesn't factor. Yep, you're right. Okay. Yep. Okay, but why were we trying to factor? Good, because it's possible that something still could have canceled out. We could have had common factors that cancel out, right? We didn't get any. And so, does it tell you, I'm not sure if it tells you can leave it in factored form or if you have to multiply it out. I can't remember. I would think you can leave it in factored form, but even if I can't, this is a pretty easy one to distribute. Right on the top, I just have my 2x squared minus 2x plus 12, and on the bottom, if I multiply that out, I just get x squared minus 6x.
No.
No, x squared minus 9. Whoops. So that's my answer. Okay, to me, that's the hardest problem on the test. Hardest thing we did in here, in my opinion, is adding and subtracting rational expressions, right? Everything else is really easier, okay? But because you gotta get those common denominators, and this probably is the longest, the hardest and most involved thing that we did, okay? There's only one of them on the test, okay? Okay, this is a lot easier, I think. If we're solving a rational equation, it's really a lot easier because we just do the equivalent of, well, we clear the fractions, right? Just like we normally would, like we've done all year with numbers. Okay, we get we multiply, we distribute through both sides by the least common denominator and cancel a bunch of stuff, right? Well, what's the first step, though? We gotta factor it. Good. So we want to write this in factored form. So I get negative 2 over x plus 1 minus 8 over x plus 6 equals, does the top factor? Nope, top doesn't factor. Good. How about the bottom? Okay, hey, listen, I really want to get through this today. This is in your best interest that we get through this really efficiently, so you get, I know you need probably some time to get questions answered to work in class, so try it. You gotta help me out. What's the bottom factor into?
X.
Okay, so my least common denominator is what then? Okay, x plus 1 times x plus 6, right? So then all we got to do is just distribute that through both sides. Right? So what happens if I distribute that through both sides of my equation? So I'm going to get okay, what's going to happen? What's going to happen? So I'm going to get okay, right? So I just distributed it through to each term. So what cancels? So the x plus 1s cancel,
X plus 6.
x plus 6 cancel. Okay, good. So I'm left with then, over here I'm left with a negative 2 times x plus 6 minus 8 times x plus 1 equals x squared plus 4, right? That make sense? So there's the key step, right? Key step is we've got to figure out what the least common denominator is and just distribute that all the way through. So we're gonna cancel all the denominators and then end up with some equation that doesn't involve fractions, right? Okay, but we wanna also remember, there's gonna be another part of the question, which of course is gonna ask you, what values of x do you have to exclude? So what are the values of x that you have to exclude? Anything that ever shows up in the denominator, so we have to exclude -1 and -6, right? And so we keep going, and what do we get here? If I distribute the -2, I get -2x minus 12, distribute the -8, -8x minus 8 equals x squared plus 4. Let's push everything to the right, so we get positive x squared. And what do we get? X squared, so if I'm gonna add 10x to this side, plus 10x, here I've got a -20, I gotta add to this side. Okay, and then what do we get for our solutions? Because I've got a -12 and a -8 is a -20 on this side, and I'm gonna push. Did I mess that up?
No, you're right, you did it right.
That's right.
You did it right.
Okay,
X plus 6.
and so what are my magic numbers?
6 and 4.
So I get the solutions then, either x equals -6 or x equals -4, but we better check and see if none of those have been excluded. And -6 has, right? So because -6 is an excluded value, we only get one solution, which is -4. Okay, make sense? Okay, question?
So, can you just go back up?
Yep.
We multiply the x plus 1, x plus 6 through.
Mhm.
Why did you multiply by the time?
By what now?
By the denominator too.
Well, you don't, when we distribute this to each of the terms, think what that means. If I'm distributing this whole thing to each of these, this whole thing is really just divided by 1. When we multiply fractions, we just multiply straight across, because the whole point here is that we want to cancel the denominators, right? What's our alternative? Our alternative here is that we could do this by getting a great big common denominator and then solve. That sounds terrible, because then we're having to add a bunch of fractions up, and we're solving equations that involve fractions, right? We don't want to do that. We want to just end up being able to solve a simple equation, and look what we got. When we got rid of the denominators, when we cleared all the denominators out, cleared the fractions, we ended up getting a pretty easy equation to solve, just a simple quadratic equation, right? Okay, so strategically, when we're solving rational equations like this, we're gonna keep track of all the values we have to exclude, but then we're gonna clear the fractions by multiplying both sides by the least common denominator to give us a much easier equation to solve. But we just can't lose sight of the fact that there were some excluded values because of the denominators. Okay? That make sense? Okay. I think we can probably skip that. We got all. I didn't think that one was supposed to have an extraneous solution, but I guess it did. Did we do that right? Negative. I think we did. -2x minus 12, -8x minus 8. I think we did. Plus 10x. Yeah, okay, so it did. So I'm not even going to do that one. Okay, what about this? Choose the graph of this. Okay, so now we're graphing rational functions.
I see it over there.
Okay, it's there. You're right. So what do we do first then? We want to factor it, right? So we want to write this as, what can I factor out on top?
-3.
And I'm left with x squared minus x minus 20, right? All divided by x minus 5. So now if I factor that trinomial,
X minus 5 and X plus 1.
Are you
Okay, so there's our factored form. That tells us pretty much everything we need to know, doesn't it? Now, if we make our table on this, okay, so are there any values we have to exclude from the domain? 5. Okay, so at 5, the function is undefined, right?
You bet.
Okay, so let's keep track of what's going on. What is happening at that undefined place, though? Is it a hole or an asymptote? It's a hole because of this, right? Because I've got
Paired zero.
right. So we get a hole at x equals 5, right? Do we have any x-intercepts? Okay, x-intercepts would be places where the numerator is equal to 0 and the denominator is not, right? So because of this factor right there, we know that at -4, we get a 0. We get an x-intercept. Okay, so now what about, what if we take our end behavior? Let's look at the limit of the function. So the limit of our function as x approaches plus or minus infinity. Well, what's going to happen there? If we just look at the ratio of the leading terms, if I take the limit as I go to negative infinity, what's going to happen? I'm really just taking the limit of negative 3x squared over x is really just the limit of negative 3x, isn't it? The x's cancel if I look at the ratio of the leading terms.
So it's gonna be positive.
So it's going to be positive. What's the limit going to be as I approach positive infinity?
Is it gonna be a slope?
So I don't get a horizontal asymptote, but I do get something else. I get a slant asymptote. How come?
Numerator is
Is one power higher.
Good, the numerator is 1 degree higher than the denominator, and so I'm going to give you easy ones to do. Notice that the denominator is linear, so we can just use synthetic division to divide that out, right? But if we do divide this out, and let's go through that process. If I do my synthetic process down here, what are my coefficients inside?
3, -3,
-3,
+3,
3,
60,
and then out front,
5,
so I end up with, what?
-15, -12, -6.
Okay, so in this case, 5 is a 0, well, and we knew it was a factor of the function because they canceled, didn't they, right? So we end up with f of x. This tells us that f of x is just equal to -3x minus 12 with no remainder, right? So that's our slant asymptote, isn't it? We don't even get a remainder on this one. So if we were to look at the graph, does this make sense? I mean, that's our graph. It's pretty boring, right? It's just a line, and it would have a hole at +5. So if I were to zoom out on this thing, the line would come down here, and then there'd be a little hole in the function at 5, right? If it kept going. So right down about there, there'd be a hole. That's it. Right? That's our function. It's got one x-intercept at x equals -4. And if we want to pick test points, we can, right? We could pick a test point over here at like -10, and we could pick one here at 0, and we could pick one here at +10. And if I were to look at the signs of the function, I guarantee what we're going to find there, it's in factored form. At -10, we're going to get positive. Negative times negative times negative over negative. So you get negative over negative is positive. If I try 0, I'm going to get negative times positive over negative. So that's going to be negative. and 10, if we try that, we're gonna get negative. So that's the only, and are you having to do a sketch? No, you're just picking the graph. I'm giving you a choice, a menu of graphs to choose from, right? You gotta pick the only one that's consistent with this. Well, this is the only one that would work. All the other ones, all the other choices, they wouldn't have, they would have done something wrong.
But if you didn't know that -4 was a 0, and you plugged it in
But,
to,
but you do.
yeah, but you,
See, you do. When you factor it, you can see that -4 is a 0 at the top, and so it's a 0,
but
right?
if you didn't,
Well, how did it wrong? You're not gonna get anything.
It's, I mean, if you didn't, you'd be in trouble, but you do, right? You do. Because the zeros are the places where the top is 0. How do you get a fraction equal to 0? 0 divided by any number, right?
yeah.
So at x equals -4, you get 0 on top, but not on the bottom, so that's a 0. Okay? Let's maybe look at, to me, those are the hardest ones. Let's maybe look at one more of those. So if I factor this guy, this one's gonna factor, we'll do this one quick. So this one's gonna factor into, I can take out a -2, and I'm left with x squared minus 5x minus 6. And then that's gonna factor on the top into -2 times, this one does work, right? So I get x minus 3 times x plus 2.
No, -6 and 1. Yeah.
Oh, what am I doing? Gosh, you gotta watch me like a hawk, don't you? So we get,
Things like that.
You don't get the one.
okay, so what's my domain? What's the value I have to exclude?
2.
So x cannot equal 2. What's going on at 2? It's an asymptote because it's a unique 0 at the bottom, right? So if I make my table, so at x equals 2, it's undefined and it's a vertical asymptote, right? So we already know that's, we're gonna get a big break in the function there. Are there any zeros?
Yeah, Google.
Where are my zeros?
6 and 1.
So I'm gonna get a 0 at 6 and at
Hey, there's a slant asymptote.
-1. And there's gonna be a slant asymptote, isn't there, right? If we divide this out,
It's going to be x squared over x.
I get 2 out front, I get -2, 10, 12, -2, -4, 6, 12, 24, right?
Yeah.
So that tells us that f of x equals -2x plus 6 plus, who cares? 24 over x minus 2, right? But if I take the limit of the function as x approaches infinity,
That doesn't matter.
the limit of f of x as x approaches plus or minus infinity, that term's gonna go to 0, isn't it? So I just end up with -2x plus 6. So that's my slant asymptote. Okay. So we get slant asymptote is y equals -2x plus 6. Okay. I get a vertical asymptote here. That tells me a lot. So already we can start to get a sense of what this thing is doing. Right? Okay, so we get here's my vertical line at y equals, what was it again? 2?
-2x plus 6.
Y equals 2 is right there. And then I get this slant asymptote at y equals -2x plus 6. So then all I'd have to do, and I get my x-intercepts. My x-intercepts we already found are at -1 and +6. So what would I do here? All I gotta do is just check a couple test points and see if the function is up or down, right? So if we try, like for example, if we try -5, if I plug -5 into my function, I'm gonna get negative times negative times negative over negative. So I get negative on the top, negative on the bottom, that's positive, all right? So at -5, that's telling me that the function is up, which it is, right? If I try a value in between here, like 0, that'd be an easy one, right? So at 0, I get negative times positive, so the top is positive, divided by negative is negative. So the function at 0 is going down, which it is, right? How about at 4? 4, I'm going to get negative times positive over positive. So positive over positive is, whoops, I did that wrong, didn't I? 4, I'm getting negative times, no, that's right. I'm getting positive, yeah. So the function at 4 goes up, which it does, it's above. And then out, finally, if I try out at 10, we'll just try like 10. If I plug 10 in, I'm getting negative times positive over positive. So negative over positive is negative. And so out of 10, the function goes down. So it fits, right? That tells us unambiguously what this thing has to do. It's the only way we could draw it. Because it's got to stick to the asymptotes and be above the x-axis there and below there and go through the x-axis both places. So we're done, right? Okay. We have a minute.
Come on,
Okay. Well, we kind of, I want to do a couple more, but
Let's do it.
I think we're out of time. Hopefully that helped.